This is the Amp Hour Podcast. Released October 11th, 2020. Episode 512. Designed for Longevity.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
Hello, nerd. How goes it?
I
was like the middle of reading a tweet. I should have not been reading one of your tweets as I about to start talking to you. Millennials, millennials.
Yeah, attention span of a gnat. Yeah.
Yeah.
Oh boy. Anyway, so yes, what were you going to say? You weren't. You were just mumbling.
This tweet of yours is dumb.
What tweet?
No, I don't know. That's
every tweet of mine's dumb.
No, let's see. One of my tweets. I don't know if you saw my troubleshooting setup. Did you see that thing? I've got a new remote debugging setup.
Oh yes, a remote thing using. I love. I retweeted somebody's comment who. This is show we're just going. We're scraping the barrel, aren't we? This is typical.
No, we're not scraping hey! This is just recapping our life, which happens to also coincide with our tweets.
with Twitter. God, we're pathetic. We need to get off
social
that
media,
platform.
Dave. It's I agree with that.
We should just ditch it.
Anywho, I'm just recording my life and then talking about it here.
All right. Anyway, somebody mentioned the comment of the week was that looking at a LED and LED, people hate it when I call it LED, looking at an LED through a webcam, you can think of that as a giant optocoupler. And yeah, I agree.
That's great. Yeah, That's awesome.
Yep.
So for a little background, I have been setting up a troubleshooting setup for someone that's helped me write some firmware. And I was like, well, how the hell am I going to get them to hard reset? So if they're writing firmware.
Remote troubleshoot it, right?
Yeah, remote troubleshooting, whatever. So I using an Analog Discovery 2, which I've talked about on here before, I'm a big fan of, and basically monitoring some rails, powering the thing on via the 82, and then also have a webcam on there like you talked about, basically to watch if the LEDs are blinking. And then there's a J-Link plugged in to actually do the troubleshooting and things like that. So
can they access those debugger tools remotely?
Yeah. I mean, it's just a VNC type of setup.
How does that happen?
They log in and then they have access to Eclipse and tools and all the other things.
Is that a remote desktop thing? Do they take control of your computer?
VNC is a remote desktop. Yep.
Oh, okay. Got it.
Yeah.
Right. I thought there was some clever portal that you could, serial link it or something, to the other person.
Yeah.
But it's easy. There probably is. Leave it in the comments down below if you know.
Yeah.
But it's easier just to allow someone to remote desktop into your computer and,
I was talking to a friend about this too, and it's this is a common problem. Say you had a test stand halfway across the world, right? You need to log in. You want to be able to see things. This is probably not the way to do it because it's still very graphically based. But
right.
Something where it was just an X terminal or X. Is it X terminal? Whatever it is, the window viewer in Linux. So you're just porting commands over the text interface, and then you're rendering locally instead of pulling the entire screen capture. Screen frame by frame by frame. That's kind of how
right.
I think some of the, maybe not VNC, but I think some of the other ones they actually do. If you're screen sharing on Zoom or something, it's literally just grabbing your screen and sending that over as images.
Sending it over. Yep.
Yeah, and then it's okay, your mouse is currently at 400, 600, and now it's got 500, 600, 600, 600. It's just stepping across. So that's not as good, but this is a kludge. I mean, it's fine.
Kludge?
Yeah, kludge.
Kludge.
I say kludge.
Kludge. Okay, what's this kludge rubbish?
I don't know. That's just how I always say it.
Okay. Kludge.
Yeah, so it's pretty
interesting.
Pretty cool. The goal is eventually, so the board that is the thing I've been talking about on here, the ABC board. It actually has the Raspberry Pi, it is like a hat, and the thought is eventually I could just plug it into a Pi, and then it has a serial interface to the NRF chip on board. It's got an open OCD interface to program it, I could maybe get a camera, like a Raspberry Pi camera and monitor it like that too. Another friend had said they did something similar. You wouldn't have like the voltage monitoring as easy as it is otherwise with like a analog discovery, but I guess you could try and script it or something like that. So yeah, I don't know. It's kind of cool.
Cool bananas.
It's probably like overdone for like if I'm not doing like 5 devices at a time, but
no, right.
For my friend helping me write firmware, like that part's great.
Terrific.
Yeah.
Have you ever tried to do PCB design over remote desktop?
I have not. Why would you do that? Just because like licensing?
Because I've had to do it for when I worked at Altium. Because I was working from home, and I can't. The restriction it was because all of our stuff was over there, and it was I can't remember why, but I was doing it over remote desktop. I was running Altium Designer over remote desktop. So it was running. So the software was running. I think it was because all of our libraries are integrated with the network and everything, right? Yeah, so it was all like, so I couldn't just copy the project locally, work on it, or I could, but then it was like harder. So it was just like probably less pain just to, like I wasn't laying out a complete board, but I was like finalizing a design or something like that.
Sure,
so I was actually
like
finishing
scrolling
off the
around
board
and like trying to, and it's very visual, right? Yeah.
Oh yeah, it's a very visual thing. And as you said before, like it's simply capturing a screen every like 5 times a second or something, or 3 times a second. It's so slow. I can't remember what remote desktop software we're using. It's not like, this was 12, 13 years ago. So remote desktop technology wasn't as good as it is now, right?
Right. And it's still not great now.
No, it's still not great now.
How far was it going? Was it in the same country? Was it in Australia still?
Oh, yeah. It was in Sydney. Yeah, so it's going from Sydney to Sydney. So it wasn't too bad. So there wasn't, but I was only getting like a couple of frames per second updating. So trying to lay out a board with, like 5 times per second updating or something is like, it was slow, but
test your patience for sure.
Yeah. But I had to, and it was over Christmas, I think, so it was oh my God, it was, but it was the only way to get the job done. So we did it, but geez, it was painful, but it actually worked. I was able to do it, and you kind of got used to it. Like you kind of got used to the torture of, placing trace, waiting.
Yeah.
Place, trace, wait.
Step,
it's
pause,
like
step, pause, step, pause. Yeah. Yeah, totally. Wow.
Yep. Oh, it was,
I didn't have to do that, but one of the worst academic experiences I've ever had was like, I was in a class. So this is, college days. I think it was a analog circuit design class, but it was on a chip. And so it was like a combination of things. Like we were remote desktoping. It was the first time I had ever used a Unix-based system. It's
right.
a Unix system. I know this. And it was remote. It was that X Windows or X server or whatever.
Yeah, right.
And then it was when you finally got in there, it was a Cadence design tool or something like that. It was like Leonardo or something like that.
Right.
One of the chip design tools. And that, you could be sitting next to the creator of the software and it would be the most obtuse piece of software you've ever used. And like, you're trying to like piece all these things together. And I remember like viscerally remember that like freak out 2 a.m, like, why is nothing working? Just like screaming at my computer. And of course, that was what, like 2003, 2004. And so like, we had a great network on campus, but I just didn't know what was going on. So I remember like trudging to the lab at like 2 a.m. and just like, I'm like, I can't do this if I'm not in front of the computer. And so I sat down there. It was the worst experience. And
right.
And that's why I'm not a chip designer, not because I'm terrible at
it. Oh, can we, speaking of like terrible experiences like that, can we talk about possibly the most obtuse PCB design software in history?
Yes, this is something.
This is really something. Somebody, I can't call up the link because I need my authority. Oh, I need forum. I did 2-step authentication to get into my own forum. Oh no! Oh no!
You can view it with you're not logged in. So
yeah, I can, but it's not letting me actually.
Just open a incognito window.
Yeah. No, it's shift.
It found the spammer. It found the spammer.
Yep, another browser. Another browser. Here we go. Oh no, it's still doing it in another browser because I must have cookies enabled. Oh, bloody cookies!
This is why you do a incognito. Control Shift N.
Yep, Control Shift N. That's what I'm doing now. Here we go. Come on, you can do it.
Anyways, this is a. It's in what software, Dave?
It's in LibreOffice Calc, so it's in Excel basically.
It's Excel. Yeah,
it's a PCB design software in Excel. Chris42 on the EEV log forum gets credit for writing PCB design software in Excel.
To be fair, so this is very similar. This is very similar to the stuff I was just talking about. It's a chip design software. It's not that different. If you go open up electric or all of these different things, they're unit cells and they're basically you're creating these different blocks and piecing them together. And you have to, the thing that always pissed me off about it is why is there no 3D view? This is creating some of the most advanced technological things in the world. I just want to click and rotate it 3D and look through it. That is the hardest part about chip design, is that you're looking at it. I remember because Dr. Darren Young, one of my not super favorite teachers at Case Western, very smart guy, but basically he had us sketching on graph paper to do this exact same thing. So if you imagine, I guess to paint a picture.
So you would sketch your own 3D view. No.
To sketch your 2D view. There was never a 3D version. So just to explain what we're looking at here, Dave and I are looking at a 200 by 100 grid of squares with spaced out with gray spacing in between. So like Dave said, it's an Excel cell that is basically colored blue or purple or gray or whatever. And then basically the idea is that you're designing this chip by, I guess this is actually a PCB.
Yeah, it's done by shorting cells together. So think of each individual cell in a spreadsheet as a bit of copper, and then you're sort of shorting them together.
It's almost like Veroboard. That's kind of a good way to think about it, right? As if you're how Great Scott, he does when you Veroboard, he actually shorts, he drags solder across multiple Veroboard holes.
I think that's what it is. I don't think it's actually PCB. I think it might be. It totally reminds me of Protoboard.
Mm-hmm. Yeah.
Yeah.
But that is actually a very similar kind of look. So I got this wrong. I was thinking this was also chip stuff. This is PCB. It looks very similar in a chip design software. At least the old stuff did. But there was never any 3D view. And so literally this professor that I had, he made us do the same kind of thing, not in Excel. You had to do it in grid graph paper, one millimeter square grids, or 1 centimeter square rather. And then you had to draw it all in there with colored pencils, and it was no one ever rotated it though. You never saw how it was actually all connected together. You had to know that these things stack up, and if you don't have that 3D view, much like people getting started with PCBs, it's very tough to visualize vias. One of my favorite things in KiCad, the 3D viewer, is actually to turn off the FR4 visualization and just look at the vias and look at how the tracks are all connected. I think that is one of the most useful things if you're learning how to use a PCB software for the first time, because making that mental switch from lines on a screen, or lines on a Excel sheet, to what a trace looks like on a PCB, it's that's a really tough leap, I think.
Yeah. Have you ever created a PCB layout backwards?
Backwards. Define backwards?
Back to front, because I did this in a PCB class once, because we had to, normally it's a 2-step process to create the negative and, and do all the stuff like that. And I went, oh, bugger that. I can skip a step. I can skip a physical construction step, and if I actually lay everything out backwards.
So you basically laid out the negative space.
I physically flipped the thing backwards so that it would. Yeah, so it laid. So pin 1 was in the opposite direction, and everything was everything.
Oh
was
no,
backwards.
I've never done that. That's.
Yeah, that was Yep.
Wow,
I thought I was being clever.
How'd it work out?
It worked. You did it right. It worked.
That's great. Yeah, that's great.
and I skipped a production step.
How much time do you think it saved you versus how much time it cost you to actually mentally do that?
Oh, it wasn't a big layout, so it was.
Okay.
It was it was more of a fabrication class than anything else. It was So it didn't take me long. I think we did what was it? It was a stud finder.
Okay, so like a LC tank kind of thing.
Oh yeah, no, you did it with a 4000. It was a 4000 series inverter or something. I think it was a 4001 or something. I don't know. Anyway, no, it was a 4040, and it only worked. And the thing only worked with one brand of chip. You could, seriously, it only worked with one brand of 4040. They were using a unique property of this one brand of 4040 chip.
Yeah.
Yeah. It had to.
Are we calling that working?
Well, yeah, it's. I can't
That's great.
remember.
That's great.
Oh man, was it like, or it was an unbuffered version of the 4040? I don't think it. CMOS. It was. Oh god, this is so many decades ago now. Yeah, I think like you couldn't use the 4040B because the B was the buffered version. I think. You had to get the non-buffered version. No, the 4040 is a counter. What am I talking about? No, it was anyway. It was a 4000 series CMOS chip, and it was buffered versus unbuffered.
It's the decades talking. Yeah.
Because if you don't have a buffered 4000 CMOS, you can actually use 4000 CMOS as analog type devices if they're non-buffered.
Oh, interesting.
Yes.
Okay.
So many early designs in like the 70s. This is before you were born. A lot of the projects out there, they would take advantage of some sort of like unusual analog properties of 4000 series CMOS logic.
Oh,
yeah, and yeah, because they're effectively just, FETs. So you can sort of use them in an analog-y type way. But the buffered version, that sort of mucked up the whole analoginess of it. So you couldn't use like feedback elements and stuff like that to actually, do things like that. So,
that sounds like a good topic for a video, Dave.
Yes, possibly. I might try and dig that up. You
should. That's interesting. Yeah, really interesting.
Yeah. It's absolutely fascinating. Like, totally not recommended for any design whatsoever.
It's an early hack. It's a hack.
It's a hack. Yeah. Using 4000 CMOS as like I've done a video on like powering a chip through the I/O pins.
Oh, yeah, I've seen that one. Yep.
Yeah. And, you can do weird stuff like that. So, back in the old days, let us know if you've ever built that into a product that was reliant upon, some weird aspect of either some particular brand or one particular type of chip.
And let us know how many times your manufacturing engineer stabbed you.
Oh, because you bought the wrong, part.
I'm just because it's like, it's on the precipice of failing all the time.
Right.
And if you can't source it or,
Yep. Oh, anyway, good fun. Good times. And I'm sure this was good times for Chris. So hats off to Chris for
other Chris, not me. Yeah.
No, other Chris.
Chris 42
for perseverance in wow.
That's something. Yeah.
PCB design software in Excel. Okay, we've seen it all now. Oh, that's great. It's great.
One of the cons that he lists is during the design process, you will destroy a minimum of 3 keyboards. Each one will be first one attack of rage. The second one was during footprint placement, and the third one will shatter when you try to run a macro, and you'll get an error which forces you to move a couple of components. That's good.
Oh man, the things we did, like, see, I'm getting too old. I don't have time for shit anymore, right?
Sure.
Whereas back when I was a youngster. A young whippersnapper, like I'd spend like months just working on some like absolutely pointless thing just because I could,
Was it because you could though, or because there wasn't was there a better alternative out there though?
Oh, maybe. Yeah. Okay.
Like I could see. Okay, so looking at something like this, right? Like a spreadsheet program like this. What I'm guessing is I didn't read the entire thing, but it's a power devices class. I'm guessing this was made at some point by a professor or a grad student, and it was just like, well, we're going to just keep doing it this way. Why the hell would we learn a PCB CAD program when we can just, we want to learn the concept, and so, we're just going to use Excel, right? Excel is still Excel, just like it was in the 90s. And like, and I argue against it because I hate that idea, as does this other Chris apparently. But like, from an educational standpoint, like, yeah, they're lazy. They want to do anything. Fine, whatever. But like, if you have another opportunity, especially as an individual, like, ooh, screw this stuff, you know, like it's like, this is just not relevant to anything else too. I always kind of like chafe at that anyways. Like they, you know, like professors say like, oh, well, we can't possibly teach a CAD program because it'll instantly be obsolete. And it's like, well, yeah, but it's a little close. It's a little closer than Excel. No one, yeah, sure, you're gonna have to relearn a CAD program. You know, if you're an Altium user, you have to relearn, you know, how it's used every couple of years anyways, just because of how the conventions change. But like, this is no one's ever going to use this. It's not even close, you know, like, so yeah.
I know it's a pointless way. It's practically a waste of time.
Yeah, exactly.
It reminds me of like, you know, when you do microprocessor classes and stuff like that. I can remember they always use their own in-house designed, you know, like platforms. No, they use their own in-house, you know, development kits and stuff. It's like,
oh God, yeah.
You do realize you can just buy a development kit from Intel or whatever. It's like, you know, or Zilog or something like that. And it's like they, you know, and it's some convoluted bloody development system. It's like, oh God, it's once again, not, you know, no real relevance to out in the real world.
Right. And I think again that because they don't want to redevelop curriculum, that's fine.
Right. Yeah, but somebody had to develop that in the first place. Somebody had to go, right, well, we're not going to use this Zilog development kit. Nah, bugger that. We're going to develop our own.
Right, but at the time, that probably was a decent idea. But again, it's probably just because it was 20 years ago, and they're just still not updating it. You know, like I feel like so much of it is that the teaching part isn't rewarded, and so like I would point people to the show with. So like first off, Brock Lemaire was one of my favorite teaching folks who's been on the show. You know, so he's at Montana State, and he does great like videos and stuff like that. But he, you know, even he kind of chafed a little bit at the idea of like redeveloping curriculum because it's really it's really involved rather. And like, so like from that perspective, I get it. Like I am the same, but like, you know, from the consumer standpoint as AKA the student, like that sucks, you know, like if you're like using a, you know, I think there's maybe some arguments for like these days of like, okay, you're going to use a PCB program, like put it in a container, you know, like put it in like a virtual box or something like that. And like, yeah, maybe you're running a, you know, a 640 by 480 window on your 4K screen at some point, but like, but it still works, you know? And it's like, I don't know. I feel like the preservation piece is almost as important as anything else. You know, that's the hard part is, interfaces change. I get it. But like, yeah, sometimes if you just like lock it all in and
I'm sure there's still some people out there using like Protel for DOS. You know,
probably, yeah.
Because like as you said, like in a 640 by 480 virtual Windows window, you know, virtual window or whatever, you know, still running that.
Yeah.
I did a video on that, you know, actually I found one of my old files. So I thought, hey, can I load a 30-year-old version of Protel? I think 30. Yeah, it would have dated to the late 80s. Yeah. You know, 30-year-old version of the software, and it worked. Like it loaded in, it loaded up, it loaded my original files. I was able to play around with it. It was dog slow. Like I thought it'd be super quick because, this is DOS, right? And, you know, and geez, these machines are, you know, 1,000 times more powerful than they were back then. And it was, it was really slow. Just the, you know, the painting algorithm of, you know, like filling in all of the traces.
Stripes are like going across, it's rastering across.
Yeah, you can see it rastering across, actually rendering the screen. It was like, was it really that bad? I could not remember whether or not it was that. I can remember there was lag when I zoomed in, like, you know, zoomed so that you zoomed into a pad, so the pad would fill the entire screen, and it took time to draw that pad.
Yeah, right.
You know, and it was like, you just take it for granted now with our GPUs that just fill in polygons or whatever, just bam like that, right?
Yeah.
But back then, no, it was individual pixels. It was like paint pixel x.y. You know, it was paint that it was, you know, calling up a routine that painted each individual pixel.
And I do remember like really long start times on like the 386 computers that we had when I was a kid. Sorry if that makes people feel old. Sorry, I had 386 when I was a kid. 286.
DOS booted up pretty quick.
No, well, we had really bad ones too. So then maybe that.
Windows 3.11 was pretty quick.
Okay.
It's faster than modern PCs, I think.
Well, then I think about like my scope that takes like 6 minutes to boot up too.
Right.
You know, so it's all relative, right? And we're still waiting on, you know, like a phone takes a couple minutes to boot up. Like I get it. Like there's a ton of stuff to do these days.
Which scope are you using?
This is my MDO 3000. That thing takes
there you go.
a solid chunk of time. Yeah.
Oh, there's your problem. Yep.
Yeah. Well,
Yep.
beggars can't be choosers, Dave.
No, I know. It's it's an awesomely powerful scope, but it's not suited for practical everyday use.
No,
I just want to check a waveform. Oh shit, I got to wait 5 minutes for it to power on and get it in the right
it's
mode.
Fine.
And
I just when I'm using it, usually I'm in the depths and I'm have it on for a couple days to try and chase down a problem. So
right, yep,
yeah,
of course.
I am doing. So now that I've got this new Zephyr thing that I've been talking about on here, I am doing that in a virtual machine. I got sick of it. I didn't want to dual boot. And I think I'm going to do that for other things too, because so I had a client that was like on pause for like 8 months and they came back and they're like, hey, we're ready to start working. I'm like, cool, whatever. I got all the board files. I got everything works fine. And then I'm like, I completely wiped out the dev environment though. Like, and I should have, and just because the computer, like my computer crashed and I had to like reinstall everything. And so now I got to go through it. And I remember like on Ubuntu specifically, it was a really, so I really like Simplicity Studio. That's the Silicon Labs like EFM8 thing that I talked about. And like, I really like it. It's actually cross-platform, nice software built on, I think it's built on Eclipse. No, I don't know what it's built on. Yeah, it's built on Eclipse. And like, but it was just like really wonky for like, it had some library weirdness. And so, okay, fine, whatever. But like, if I would have had that in a virtual machine, I could have just like clicked a button and it would have just come up as, a virtual machine. And from now on, projects get their own virtual machine. Storage is effectively free. And like the USB pass-through I was kind of worried about, but like that part is like rock solid. I've been using the VMware, whatever it's called, like not the server one, but the other one, workstation player. So yeah, it's great. And yeah, now every customer gets their own little virtual machine, and we're off to the races. So
got it.
Yeah.
Right. So you can just save that setup and it's ready.
Ready to go.
It's always ready to go. Okay.
Yeah.
Right. See, because I thought like dual boot was the duck's guts, wasn't it? But you're saying like virtual machine is more if you can save configurations and things like that. I can see big advantages in being able to save configurations and whatnot.
Yeah, and I mean, and you could have a Windows one versus a like basically it's kind of platform independent at that point. It's like. The real problem with I am on a dual boot machine right now, but all the graphics stuff is all messed up from NVIDIA, and so I don't know. My Linux side of the machine is just like totally messed up right now. So I'm like, all right, well, I don't have time for this right now. Like it's just like I don't want to keep dealing with that. So now I just stick in a virtual machine.
Right.
So
cool.
Yeah. I hope it works. I'll let you know how it goes. I'm sure I'll have some choice words if it doesn't work.
Right. Excellent.
So to go back to the educational thing, did you see the link about the Coursera courses?
No. No.
University of Colorado Boulder. It's on the Ampower subreddit, but CU Boulder or University of Colorado Boulder.
Oh, there it is. Yep.
They are offering like a whole bunch of like IIoT classes that look pretty interesting, actually. Like 10 hours at a time or whatever, but like, or sorry, I guess those are the projects that are in there, but there's like 10 different courses and they're like $500 each. So not cheap.
I was going to say the whole course is $6,000.
Yeah.
Yankee bucks.
Yeah. But it's actually like towards a master's degree if you want to. So like,
okay.
So you could take like a one-off, you could take a one-off for like $500 or you could like, start, I think you have to actually apply and do the other stuff. But I was just like, this is the most targeted program I've seen so far on this sort of thing. I've been following, I get the Coursera emails and this is the one that's just pretty close to, industry style things. So that's kind of cool.
Yeah, because I'm surprised that they're using Coursera for this. Normally the universities offer them direct, don't they? That's
a lot of them do branded. So like edX is like that's like MITx and Harvard is I think it's like there's a couple big players, but
right, because there's lots of online masters these days.
Yeah.
So
yeah, and this is saying master track, and so it's all like BS, whatever. That's what I wonder about this stuff. Though, like I would really curious to hear from people like if you're hiring someone and you see this on someone's resume, like you can go check it out, but like it's not like they have a master's degree from CU Boulder, which good school, whatever. But like, does it have the same impact? That's ultimately what it comes down to. At the end of the day, that's all that matters. Is like, can it get you a job?
I wouldn't care because once you've got experience, your qualifications go down the bottom of your resume.
Totally. But I'm just saying it's not you or me as hiring people. I think it's more also like institutional type of things, right? So like, would this get you past the HR to say like, oh yeah, I've got some master, I've got a master's degree, or whatever? Or
I think it would, because they're checkbox tickers, right?
Yeah.
So do you have a master's degree? Tick. And if you can legitimately show, they don't care what quality of master's degree.
Yeah.
Right? They don't care. As long as you meet that tick box and check, that's it. Then your resume gets passed to the next level.
Yeah.
So, yeah, I think it would.
Yeah, I think it depends where you are in your career, of course, as well,
Even one of those like non-accredited, non-university masters in quote marks, right? That would get you through the tick box. Right?
Uncle Bill's master's program?
Yeah, Uncle Bill's masters, or whatever. Like, I'm sure, we could give examples of, I'm sure you've heard of them. They try to give themselves like industry sounding names,
like contextual electronics.
Yeah, contextual electronics. Yeah. And but they will get you through the checkbox. I'm pretty sure. Let me know if you've got one of those sort of non-accredited. I'm talking like non-Sydney Accord, non-Washington Accord kind of.
What does that mean?
Accredited thing. They are the international standard, right? So if you want your qualifications to be recognized in other countries, right? Most countries are signatories to these accords. So there's the Sydney Accord, the Washington Accord, and the what's the other one? I've done a video on this.
Okay.
And these accords are ratified by the various international bodies, right, in various countries. So here it'd be the Institute of Engineers, or Engineers Australia or whatever. And if your degree meets a certain standard, whether it's a master's, a bachelor's, or a diploma or whatever, 2, 3, or 4 or 5 year degree or whatever, it meets one of these accords, then technically you can move to another country. It's internationally recognized. You can join the local engineering. So I could go to the US in Colorado or somewhere, and I could get accredited as a professional engineer there if I meet a certain accord.
Okay.
Yeah. Right. And some of these things will claim that they'll use wording. You got to be careful. They'll use wording like, we're not accredited, but they'll use, real sneaky wording like we're equivalent to the Sydney Accord or whatever. But they're not actually accredited. They're not officially accredited. Right. So you got to be careful.
Arduino compatible header.
Yeah, Arduino compatible. Sydney Accord compatible.
Yeah. Yep. Right.
So yeah. Anyway, so that's So the proper ones will be accredited. And this is was talked about recently on the forum. Somebody asked, "Oh, is this 3-year degree I'm doing? Is this equivalent to a 4-year?" And, we're going through all the various things that actually related to that, the various technical things. And the bottom line is, no, it wasn't, because it didn't meet the certain accord that you needed to be internationally recognized as a 4-year degree. Yep. So, you have to be careful. What? Well, I know it's boring as batshit.
I was laughing because I was scrolling down for the new thing, and you made that noise, and I had just scrolled past a picture of Kermit, and I was like, "Oh, that sounds like Kermit."
Okay. Anyway, I've done a video number 1175, how to become a professional engineer, and it talks about all the accords and things like that. So
got it. Okay, cool.
Yep,
that's great. Well, like I said, I'm mostly interested in if people are actually taking these things. Like at the end of the day, that's like some of the knowledge is interesting, but like I don't really have any good way to know how good these classes are. Like some of the stuff they mentioned too is like modeling and debugging embedded systems is like System C. It's like, okay, well, yeah, I'm sure that's useful in some places, but like, is that directly applicable to anything I need? No, probably not. And like same thing with like, using, I don't know, I think they were using a bunch of PSOC type stuff. It's like, oh, PSOC's cool, but they're so expensive. I'm not using them these days. Like it's just, and so like, how practical is this if I wanted to go and take something like this? So
right.
Generally curious.
Yeah, really, it's not something you can do on a whim, right? This is very expensive, unless you got oodles of cash to throw away. You've got to be serious. It's because generally speaking, it doesn't it's okay if you list, I've done a couple of little short courses on your resume or whatever, but it shows that you're actually proactive and learning.
Yeah, you're engaged
stuff on your own.
Interested.
But generally it's like kind of meh. It's not as is most of these. Once you've got experience, everyone looking at any engineering person looking at your resume just goes meh at any formal experience. Oh yeah, got a degree, meh. Done this course, meh. It's like, what have you done? That's all I care about.
It would make sense if it was it was like leading edge technology you couldn't find anywhere else. Like that could so say you were doing like a machine vision thing and you just can't go and pick it up and do a thing. Of course might make sense for those sort of thing. But if it's
absolutely.
Okay, I want to go build a Blinky board. It's well, there's lots of ways to do that is not a $500 course,
Yes, so. If you're going for as I said, let's say you're going for a vision engineering job or something, they need someone's specific vision engineering experience. Having that, you would then, this is why you tailor your resume for each job, right? Don't just send your standard resume to each job. Right, you look at the things that they're after, and then you highlight those. And I would then move that right to the top of my resume. Right, if I've done a short course on some course or online or at some university, just one little class that's done vision systems. Right, I'd put that as a key highlight right at the top of my resume. I would definitely do that. You wouldn't bury it away down the bottom like you would for, you're going for some other power supply job. They don't care that you've done a vision engineering course.
Well, what if you're trying to remotely troubleshoot it though, Dave?
Right. And what's that got to do with it?
Well, you set up your vision system
right,
to do your remote troubleshooting. Come on.
Right. Oh boy. Anyway. Yep. Dublin Accord is the other one.
Dublin.
Washington, Sydney, and Dublin are the 3 accords. Mental block. Yep. Anyway.
Someone had asked on the forum for some guidance. Again, this is a very student-centric kind of thing, or school-centric thing.
Whose forum are you talking about?
This is on the subreddit, rather, Guidance for Electrical Engineering Students.
Oh, okay. Yes. Well, that's not a forum. Reddit's not a forum, is it? Reddit's Reddit.
Reddit's the front page of the internet, Dave. That's what they say.
Right.
Yeah, gross.
Isn't it like going down the toilet, Reddit or something? I don't know. I don't use it really.
Yeah.
I don't.
I try not to too much. It's snuck back in my life, unfortunately.
Oh, right.
Like caffeine, it is snuck back in my life. They both are very addictive.
Who's?
So this is Pablo the Ghost Beater.
Obviously, yep.
Yeah, handles being what they are. Let's see. As you know, the curriculum is extremely challenging. Yep. And we have doubts. Yep. Did you or Dave ever struggle like this with the understanding the fundamental of the and whether fundamental understanding of the core concepts is as strong as it should be? So I should have read this beforehand.
Yeah, we should have. The curriculum is right. He's doing a BS in electrical engineering. The curriculum's extremely challenging. Yes, it is. And I'm sure it's not to do with the electronics part of it. It's to do with the maths and the physics. It's the maths and the physics. And I always hated it. It was like, oh God, it was like, it was just not my thing. It was just, yep. Yes. So we did. Everyone struggles with that. Unless you're a math nerd.
Yeah. Some people love the math and that's great.
Great. Excellent. If you love if that's your bread and butter, an engineering degree is probably going to be a piece of cake for you. Right. I would
agree with that. Yeah.
Yep.
And I think honestly, when I think about the learning process in general and how long it took me specifically, not other people, me specifically, to get to the point of actual light bulb turn on understanding, it took years sometimes. It really did. And so much of it, unfortunately, with education systems, it's so much of it is the focus is on getting through it and getting to the grade and getting to the next thing and not flunking out. It's there's some practical stuff in there. That sucks. And that's where the struggle comes in, I think. You have to pass calculus 2. You have to, do this, you have to do that. And it's like, but really you're there for the understanding. And if you can try and pair the actual it's all about mental models for me. Like being able to visualize a thing and then reconstruct it. So I think about things like my physics of semiconductor class. I think I've said on here before, I wish I could take it now, because like now that I actually have mental models built up around like just how a diode or an LED works, right? And then like thinking about like, talking about, what was that?
You okay? Are you saying it needs to be contextual?
Oh, nice. Yes, yes, I am, Dave. Yes. But like thinking about that, and like thinking about like the carriers and things like that, and like the math of it all, that's when it all makes sense. Once you've used an LED enough to be like, oh, why is it 0.7 volts? And then you like go and you look at the physics, and you look at like all the materials and like the electrons specifically, that, and like how that stuff builds up and the voltages that builds up. It's like, oh, that is friggin' interesting.
Well, it's not to everyone. I'm sorry. It's like, no, it's seriously not interesting to everyone.
Well, I just mean like
there are a lot of engineers who could not give a shit.
From the top down, it's much more interesting, because at the end of the day, it's an LED turning on, versus the bottom up where it's just like, oh, equation, oh, equation, oh, equation. What the hell am I doing this for? It doesn't make any sense. I'm doing this for the grade, and then at the end, I guess the LED may be lit up. Who knows? Like I'm still stuck in the math over here. Like so.
Yep. I would like to think that any engineer would find that interesting.
Well, yeah.
But any true engineer would find, once they realize all this sort of stuff, they would go, oh, yeah, that's interesting. But, unfortunately, there's a lot that just don't care. And, and you can still be a great engineer without caring about that sort of stuff, without finding that sort of stuff interesting.
Yeah, like you can be attentive to detail and care about your job and all those other things. But, yeah, I see.
Yeah. Because, of course, engineering is an applied science, right? That is literally what engineering is. It is applied science. You apply it in a practical way. It's, very, not that often do you have to go back to, basic physics principles and things like that.
Yeah.
Yeah. As I said before, you can be an electronics design engineer, go your entire career without solving an integral or without going back to basic physics. You can have your entire career without having to do that. But others, I don't know, you might find yourself in a field where, no, you are dealing with that physics on a daily basis, right?
That's right. Yeah. I think it depends. It depends on which rabbit hole you dive down, right? I mean,
exactly.
If you're building the spice programs, if you're a Mike Engelhardt and you're building the spice programs, like, you better know your math and your physics and your programming really well, right? If you're, making, if you're applying,
well, that's almost pure math. That's not physics. Sure. That's almost like you'd need a degree in pure maths to do write simulation software. Perhaps I would be guessing that you wouldn't actually get into the physics of it unless you're modeling things like, the thermal properties of components. Like you're building a model for how a semiconductor changes based on temperature and things like that, for your Monte Carlo analysis, for your thermal Monte Carlo stuff, and all that sort of goody stuff. But I don't know how many people out there have written. Well, we haven't had a guest on the show who's written.
That's right. Yeah, right.
Simulation software, but there's not many. There's not many out there.
Yeah.
Oh boy.
And then when I think about the other things that I've done in engineering, though, like as much as, knowing the physics might be a very important thing, like some of the better engineers I knew were the ones who were building relationships with like FAEs and salespeople, and like understanding how to get early information and how to like navigate meetings and how to like construct project schedules. And, like engineering is just so broad that it's, you gotta be well-rounded in some ways like that. Like, around here, we like electronics, of course, but like some of those other soft things help as well. And as much as I don't particularly think that, at University System do a great job with that. They tried, at least with me.
Right.
But I don't think it was like, I don't think me taking 3 semesters of Japanese ended up helping me
right.
with any of my class stuff.
It was the thing to do in the 80s because Japan, all the best stuff's made in Japan, right? Back in the 80s.
That's right. Yeah, and or the early 2000s. Apparently, I was a little behind the curve.
Right. That was still a carry. I think that was still a course carry on from the 80s, just like using an old dev tool.
Yeah. Well, it did actually. So when I was watching this PS5 teardown, so this is a link that's on the subreddit as well. There's a PlayStation 5 teardown from an engineer at Sony, and he's like just talking in Japanese the whole time, and it's like, oh, I remember like listening to a bunch of Japanese. I don't understand anything these days, of course, but
right.
I always like the sound of Japanese. So,
yep.
And it is a great. Have you seen this thing, the PS5 teardown?
No, I haven't. I didn't even know it was physically. Is it actually released yet?
I don't know.
I didn't think it was.
I think it's maybe pre-order, but I don't really.
Right.
I don't play games, so.
Who did the teardown? Who got one?
It's Sony did it.
Oh, Sony did it.
Yeah, that's what's interesting. It's on the PlayStation YouTube channel. Yeah.
Oh, okay, right. I'm gonna have to go check it out.
He takes it all the way apart though, and it is beautifully built. I mean, it's,
who takes it apart? Is it one of their engineers or is it?
I think so. So okay. I don't know. They don't say who it is. I don't think they do.
Right.
But yeah, he's just explaining it the whole time. It's a brilliant idea, actually. From I had not seen this of like a company tearing down their own thing like this, but it's like
right.
They know it's going to happen anyway, so why wouldn't you? Like it's great.
Yeah, no, of course. I know that's totally getting ahead of the curve. Why not? And I'm sure it's got huge production values, right? Sure, it's got nice production values.
Beautifully done, like the.
Oh, here we go. No, it's Yasuhiro Uturi, the vice president of the mechanical design department, hardware design division. So they've got one of their heads.
The case design on this thing is amazing. So it's like all built around the fan system, and it looks like 2 pieces of paper kind of folded over, like it almost looks like a book that's being peeled apart. But the whole center thing, like
okay, so it's mostly about the mechanical aspects of it. That's why they've got the vice president of mechanical.
Yes, that's
sort of like rather than one of us.
I mean, they point out one of us, one of us.
Yep.
Yeah, I mean, they point out like they have like notations of like what everything is, but they don't. It's not like deep dive and anything. But also at the same time, like it's an AMD Ryzen processor on there. It's like, what are they going to do? Like, peel that thing back and like look at the silicon? Not really. So I mean, the heat sink though is massive. It's awesome. So.
Right. It's just all a pure mechanical and it looks like thermals and physical construction tear down. They don't really go into.
Yeah, I guess so. But I mean, like, I don't know. It's just a computer, really.
Oh yeah, show on the board. There you go.
It's a fancy desktop.
CPU is 8 core. Oh, okay. AMD Ryzen Zen 2. Okay, whatever the hell Zen 2 is. I don't keep track of those things. So.
It is one of the newer graphics lines from AMD.
Yes, of course.
I guess.
I don't know.
Yeah.
Big chunky copper on the board. Love to see big chunky exposed copper.
Yeah.
It always gets me excited.
Yeah, no, it's beautiful looking product. So.
All right. Can we get back to the question because Pablo the Ghost Beater had a question specifically for me.
Oh yeah.
Which is an interesting question. Lifting the curtain.
This is a little it's a little
what?
Hero worshipy,
Hero worshipy. The question is also question for Dave. We know you are an off the cuff YouTuber for the most part. Pretty much that's entirely or almost okay.
No, I'd say your fundamental Fridays things were used to be, prepared.
Not really. No, I'll go into that. But sometimes the knowledge and details you have about a particular subject are incredible. Do you spend time ramping back up on the video subject matter?
Jeez, Dave, why did you want to read this, Dave?
Prior to shooting, or is all of this knowledge just in your brain? Okay, it depends on the video. Obviously, like if I'm doing a teardown video, for example, that's just stand behind the camera, press record, tear it down and my instant reaction and first comment as I
point at
tear
things
it down.
and talk.
Right, yeah. So I don't tear it down and sit there. Oh, this would be interesting to talk about and make notes and things like that. It's like that's why I'll either miss things all the time or I'll rant on for 10 minutes about some obscure screw right in the thing because I don't know. I've got a story to tell. It just pops into my head, right? It's stuff like that. So yes, all of my video, I don't do scripts at all. All of my videos are off the cuff. I'm sure you don't do scripts either, right, Chris, when you're doing your videos?
That's correct. Yep.
Fundamental. Yeah, we just start yapping. For like something like a Fundamentals Friday video, yes, I'll do some prep work. If I'm doing the whiteboard video, I'll do some prep work just to make sure I'm not goofing something, right? Because I don't want to, because
I'll usually like record it 5 times, and the first 4 times are train wrecks, and the 5th time is like
mine's pretty much the first time. Like often I've done a video explaining this. My supporters have access to it. And like explaining my process and stuff like that. I'm pretty much off the cuff. Like even though I've done some prep work beforehand for a Fundamentals Friday video, and I might have some, like I'll literally just have points. Like I'll go, oh yeah, I probably want to talk about it, like a Post-it note with a couple of asterisk points on it, right? Just so I don't skip a step, pretty much. So I just outline that, but I don't know what I'm going to say until I actually press record. Right, it just sort of comes out, and like you, I might have to do it maybe twice. You might do it 5 times or something.
Yeah, 5 times.
Yeah,
they're shorter for me.
Yeah, or my former sidekick David, he used to do it 10 times. Right, because he was like super paranoid about getting it all 100% absolutely perfect. Right, whereas I don't care. It's like, good enough, And I think I got my point across. Which is, so I'll make up some point that I'm trying to get across and I'll press record and then I'll start yapping. And if I think in real time, as I'm saying it, my brain's thinking, is this right? Is this getting the point across in a reasonable way? And if not, I'll stop and I'll say it. I'll say it in a slightly different way, perhaps. Generally, most of it's all pretty much off the cuff and it's coming from my head. Although, there's formulas that I won't remember, right? There's details, there's math stuff, right? Just like you said that you didn't like the maths. It wasn't your thing, right? Same here.
Still not. Not past tense, present tense as well.
Like right now, if I asked you to solve a triple integral, would you be able to do it?
No.
No, see,
hold a gun to my head. I still
wouldn't be able to do it, right?
Yeah.
Yet I learnt that stuff, right? And I have no idea, right? I couldn't. Yeah, hold a gun to my head. I could not do it, right? Even the most even some formulas you'd think are really fundamental. I've totally forgotten because I've never used them since I studied them.
Yeah, it's an atrophy thing, right?
Yeah, and it's yet other. Yet I will remember the most obscure detail from a magazine article I read back in the 70s, right? It's really weird, the stuff that sticks in my head.
Why do you think that is? Is that something specific, like an image, or is it because like the experience that you had around it? Like what actually?
Yeah, it's just me alone with my magazines, and that's all I had. So I was hyper focused on it, and I can still picture me, reading that magazine in my shed. I can still I can visualize it. I can
That's great.
Yeah, it's it's weird. Yet I can't remember the formulas that I had to study for. Because I just didn't care. I was like, oh shit, I've got to learn this crap to pass this.
Right, exactly.
Maths
it's just to get through it.
Yeah, exactly. Yeah. And it didn't interest me, so it didn't stick in there. And so yes, a good lot of the stuff just pops out of my memory. It's like, this is why I've always said, because I've been, a hobbyist since I was like 5 or 6, right? And then I was like, by the time I went to formally study engineering, right, I like to think that I had, I had probably like a decade before I studied engineering. I had a decade of this hobby experience, just, reading and memorizing all this stuff, which I didn't really understand at the time.
Right. Yeah. Yeah. You like unwind it in your brain, right?
Yeah. Like, I'm 10 years old and I'm reading about, there's something I don't really understand. I just know I love engineering. I love electronics and stuff. So I'm just, absorbing all this stuff. And then when I go to learn it, formally, boom, it just floods out. And it's like, oh, it just pops out, right? I'm the one who's always putting up my hand, like answering the questions in the class, because it just, boom, I just know it. It just like floods out later because my head's just full of all this stuff that when I went to formally learn it.
And it's been flooding out ever since, folks.
It was flooding out ever since. Leaky tap. And
right.
It's so even if you don't understand what you're learning at the time, I find it always pops out later. Yeah. Like, or one little experience I had in a job 20 years ago, that'll just suddenly pop out in my mind. Yeah. When I'm talking about a board, or, I'm going through a teardown, I'm talking about a layout or whatever, boom, out it comes. This little obscure issue I had 20 years ago just pops out. And, I'll waffle on for 5 or 10 minutes talking about that issue.
See, I think that's a good point, though, like that from a learning perspective, too, right? So to go back to the struggling and stuff like that, like so much of what Dave's talking about here, what we've been talking about is like pattern matching, right? That's what humans are really, really good at, is like pattern matching.
Yeah, the brain's great.
And so some of it is just honestly getting exposure to it, struggling with it, like Dave said, like sitting in your shed, just memorizing things, but also like just kind of struggling with things, trying to figure out what's going on. And so I think one of the problems is that, like, from my experience for like going into an undergrad program that was like electronics, I just didn't have any experience there, right? So Dave had all this stuff popping on his head. I was like, there's nothing here. It's just all I had was the math to lean on. I didn't have anything else to contextualize against. And so like that's the problem. So that's why we always say go and try and get some of that outside experience if you can, not just for, contextualizing what's actually doing here, but also to just keep motivated, right? Make sure you honestly make sure you like it, right? That's the other thing. I know some engineers that just don't like being engineers. And it's like,
yeah, I know.
If you figured out early enough, maybe you could switch to mechanical or, business or whatever floats your boat, but like figure that out as soon as possible.
That was my biggest shock when I went to university. It was like, meeting the other people. It's like, I'm super excited about electronics, right? Yeah. Nobody else gave a shit.
Right.
It was like, I'm talking like 95% plus.
Yeah.
Did not care. It's like, why are you here if you don't like it? If you don't care, why aren't you enthusiastic about it? It's like, wow, what a shock, I
think that's totally normal, though. I think that, like granted, the timing was not great, but like, late 90s, like there was a resurgence of, like there was all the opto stuff. And like, so there was like programs that were popping up a lot and people were like, oh, you can get really good jobs in engineering doing this kind of thing. And like,
right. Yeah.
I won't say that didn't influence me. Like, yeah, the money was an interesting thing, but that some people are just doing it for that, and it's like that
they're doing it because their parents want them to study something, or their friends went into it, so they go, I don't know,
exactly,
I'm doing engineering, I guess, it'll shut my parents up.
Figuring out if you actually like it is like one of the most important things, because if you do, right, if you get to really like it, like a young David L. Jones did, right, you can get through that crap math, like you're just like, oh yeah, it's just the thing I have to do, and it's you might have a good reference point for the things that you find interesting outside of the math. So
I find that there's vastly more distractions these days. Like back when I was a kid, right, learning electronics, right, there was no other distractions.
So they just had Twitter. They didn't have TikTok. Is that what you're saying?
Exactly. No interwebs, like there was nothing. There was just me in my shed with my magazines. That was it, right? That was it. That's why I read those things over and over and over and over again. And it was like, and that's why, like, I will, when I'm thinking about, like, when I'm doing a repair style, like, I might tell a story, but that's not something that I might go, oh, this is a trap for young players right here. That's not necessarily something I've been trapped with. That's because I read every serviceman column in Electronics Australia magazine going right back to the 1970s. It's right. Even before that, I went back and read all of the columns. So, that had this. So these things will just pop out in my head, 30 years later.
Just repackaging old material here, folks.
Yeah, I'm just, exactly. It's like everything I've read.
Aren't we all? I mean, even you and I right now, we're repackaging old amp hours, right?
It's totally. That's been our career for a decade now. It's just
That's right. Yeah.
repackaging old shit. Even for the second episode, we'll just rehashing shit from the first episode. I think.
Why not? Right.
It was,
right.
Hey, it's telling
recycle,
stories.
reduce, reuse. Okay.
So yes, to answer poor Pablo the Ghost Beater's question is, it's half and half. There's a lot of shit up there I don't know until I start talking, and then it pops out.
Yep.
And other things, I might do some prep work, but no, I don't. I'm not like there's other YouTubers out there who do engineering videos, and they will do a ton of prep work. So don't necessarily think that because your favorite YouTuber, don't necessarily think that there's some super genius is what I'm saying, is that they know every equation off the top there. They know everything off the top of their head. No, it's there's a lot of YouTubers. They will all admit that, Google is your friend.
Totally.
It's like, totally.
Yeah.
It's, But even then I get things wrong,
Yeah.
All right. Yep. So, but I like to think that, I'm knowledgeable enough that once I don't have to refresh much. I just got to go, oh yeah, I remember that formula now. Oh, I remember how that works. It all just sort of like flows back in there, right? It's all kind of, it flows back. It comes back pretty quickly. And then I will figure out my own way to explain it. That's why often, I will not do a tutorial video unless I can think of a different or better way to explain it than somebody else has done before, right? If I'm just going to rehash somebody else's work, I'm not going to bother to do it. I'll just go, well, just go and, buy this textbook or whatever, So there you go. Thank you, Pablo. That's an interesting question.
Other places for Pablo to go and learn things. One thing is reference design. So I've been following this lately. This is when I posted about MPPT. This is
maximum PowerPoint transfer for those who don't
or tracking. I thought it was
maximum PowerPoint. Tracking,
I didn't realize.
Yeah, once again, it's one of those.
I didn't realize. Whenever I see these things, I always thought they were built into the chips, and the actual charging chips. I thought they had to have everything in there, but I didn't realize that. So the chip that I'm using, the reason I found this is because it's actually the chip that I'm using on my board, my recent board, but it's got like a variable impedance input for like a solar panel, and so you can actually do MPPT using that. And it's got an ADC internally.
Why are you using that
on my board?
I didn't think that was the stuff that you're doing. I didn't think that was actually related.
So I wanted to. Well, honestly, it was kismet. It was because I was looking through the list of things that I wanted, and one of the things that I really wanted was a way to back power other stuff. This BQ25895 that I put on the board, it has a thing called PMID. I'm not sure what that stands for. It's an acronym for something, but it's basically it's like a high speed charge controller, right? It can do 3 volts to 3.4 to like 14 volt input. So it can take like solar panel or 12 volt battery inputs. And then it'll bucket down for battery charging. And then there's also just a system output. But the cool thing is then you can turn off battery charging and then instead back power something else like USB on the go. And so because I've made this into like a Raspberry Pi hat, I wanted to be able to go and back power that Raspberry Pi without a separate supply. And so the idea is that it's a solar panel input, charges the battery. You can turn that off, then go and power the Pi using the solar panel if you have it. You wouldn't be charging the battery at that time. But the idea then is the solar panel is just so you can have a solar panel to power this whole mess of a thing. And it had said MPPT in like the DigiKey thing and like some of the marketing specs, but I couldn't find anything else. Turns out it's just this application note where MPPT is like this algorithm where you're basically trying, you basically excite the solar cell and then you kind of back off and you see what it does. And then what you do is you actually ratchet the input impedance using over I2C. And so this app note here is basically how to go and do that. So you have an internal ADC, you measure the voltage, you see what the voltage is, you see what the current is, those all measured internally, and then you like step up to the next level. You change the impedance, you step up to the next level, and you basically go until you go over the top of that MPPT curve, and then you get the maximum. And then you can like just set this up as an algorithm. the microcontroller controls this thing and set it up as an algorithm, and then you can get the maximum out of your solar cell. But then when the sun changes, throughout the day, you can rerun it all the time. I thought this was always built into the actual charger, and I thought it was actually built into this charger that I bought and designed in. But no, it's just capable of, you can do that from a micro externally and then modulate the input to do that sort of thing. So kind of cool.
There are specific MPPT chips, though, that will do this internally, but yours wasn't.
Yeah, I forget what the part number was. I was talking to my Dave Young, actually. I was talking to him about, he's got a board that he designed for Voltaic, which is a solar panel manufacturer, and he designed a board for them that is like a reference design. And instead, it has the BQ24650, and that actually does have MPPT internally, but it's got a whole bunch of like external FETs you have to use, and then there's like really, really beefy diode, and then it's got like really high leakage currents and stuff like that too. So it's really high powered and it's good for big systems, but it's not what I needed. So I can still do it, but it's
Gotcha.
Anyway, so it was cool. I'm very excited about it. I got to write the algorithm, but it's neat. Yeah, and the app note teaches me. So like this is all going back to Pablo. You can go and learn this stuff from resources like this.
Yes.
Yeah.
App notes.
Love them.
Yep. Yeah, I'll get lots of inspiration from app notes and things like that. They're really cool.
There's also YouTube channels, of course. There's GitHub repos. Did you see the GitHub repo with the where is it? Someone built a 1 megahertz to 6 gigahertz USB based vector network analyzer. Like, holy crap, this thing is amazing.
Yeah.
So it's a Spartan 6 on board. It's got all the hardware. It's his first attempt at a VNA, which is crazy. But this could actually be like a candidate for a low cost VNA. We'll see.
I thought there was a low cost. Isn't the Nano VNA the duck's guts? Everyone's
yes, but that only goes up to a gigahertz, I think. So.
Oh, okay.
Like even getting to 2.4 gigahertz, right? So if you need a VNA for like testing your antenna on your Bluetooth thingy or your Wi-Fi thingy, it's pretty expensive still. I think there might be one or two things out. Oh, there's the one that Shariar reviewed. There's like a handheld one that's from a China brand that I looked at.
Right, yes, I remember.
It's just okay.
Was that his conclusion? That it's just okay.
That was pretty much his conclusion. I'll link that into it. Was, I mean, it's a great review, of course, right? It's Shariar, but
oh yeah, of course. No,
yeah,
very
it's
in-depth.
called Deep Ace, Deep Trace, Deep Ace. I forget. I think it's Deep Ace. But it's a handheld, which is cool, and but not what you want. If you need like really good dynamic range, that's not it. But if you need handheld, then it's great. That's my summary of his summary. Just a remix.
Speaking of battery charging. Can we talk quickly about my electric car?
What about it?
Because I fast charged it for the first time.
I thought you were going to talk about something else on it.
What? Well, what do you think?
That photo you sent me. The wanker plates.
Oh, right. No. Okay. Let's not talk about that. All right. Nope. Okay. Nope. Okay. Charging the electric vehicle. Fast charging, right? I was, fast charged it for the first time. So I went and plugged into an Australian designed and manufactured, thank you very much, Tritium charger. I'm going to ask them to maybe do an amp hour episode. Yeah. That'd be nice. And so they have these 50 kilowatt chargers, right? 50 kilowatt capable. They might make bigger ones. But anyway, our National Roads and Motoring Association, they've installed these free super DC fast chargers around, in various locations around. So I went to use one and I thought, oh, great, I can charge at 50 kilowatts. And I knew that my car could do 50 kilowatt charging. That was like the maximum it'd charge at, right? And if you don't know, there's basically 3 levels for the Hyundai Ioniq. There's the 2.4 kilowatt or 2.2 kilowatt, which is your standard 240 volt wall outlet, right? And then there's 7 kilowatts, which is single phase AC charging. It won't do 3-phase charging, which would be 22 kilowatts, unfortunately. It won't do that. But then it'll do DC fast charging, which is up to 50 kilowatts. So I thought, okay, this is a 50 kilowatt station. Nobody else is using it. Like there's 2 of them there. Nobody else is using it. because there's not many electric cars in Australia. No one else is using it. So I should be able to get the full 50 kilowatts. So I plug it in and I go look at the display on the dash and it says 25 kilowatts. And I, what the hell's going on? And I'll send you the link here.
I was just saying, were you like shouting? You're like, I want my money back for my free electricity.
Yes, it's in my video on my second channel. You can go see it. And I felt ripped off. And here we go. I'll give it to you in the Zencaster chat. Okay. There it is. And 25 kilowatts. And then I hopped out and we're talking about it and stuff on camera. And then I went back in, checked it again. It's dropped down to 11 kilowatts. And I went, what the hell's going on here? I've ripped off. Like, is there, where's the limit? Like, I figured it was the car. I got my free
power, but it's not showing up fast enough.
Yeah, I expect it. Like, I'm using a 50 kilowatt charger. Why can I charge at 50 kilowatts? It's because I've got the new model. If you had the old model, it would. So, Chris, take a look at these graphs and we'll provide a link down below. This is fascinating. They've shown the different models. The one in, have you got the graph there?
I have the graph, yep.
Okay, the one in green is the previous model, right? That's like the 2019 model with a 28 kilowatt hour pack, right? Mine's got a 38 kilowatt hour pack. And both of them charging at 50 kilowatts. Mine will only charge at 50, up almost 50 kilowatts, up until 50% of the battery pack. So if it's above 50%, then they step it down. The bastards, why?
It's because it's probably in voltage limit mode at that point.
Right? No. Take a look at the previous model.
Oh, yeah, you're right.
The previous model has a flat line right up until 80%, right? This one has the yellow one is my one. This is the new 2020 model. It's got steps. So at 50%, it deliberately steps down to about 35 kilowatts. Then at 60...
So you don't think it's... What do you think it's for? Like heat? Heat then? Or what do you...
It's for battery management. I think it's for pack management, longevity of the pack, because they're now offering 8-year warranties on these packs. Yeah. So I think they're being super cautious by going, it probably wasn't a good idea to allow people to fast charge these things right up to 80%. So they've implemented this step algorithm. And I happened to be just on the cusp of when it was 25 kilowatts. So I started charging at 74% battery, and I was getting 25 kilowatts. And then by the time I stepped out of the car and then came back, it had dropped down to 11, which is I was going into the next step phase of the charging. And this is only on this new model.
Do you think maybe they'll update it later, though, with like firmware or something, like if they figure out better characteristics?
No. This is very deliberate. This is
a money-saving thing. This is money. This isn't capability.
No. This is capability. You can fast charge that pack right up to 100% if you damn well want to.
But they want to save their money on the because of the warranty.
They want to save because they're offering 8-year warranties on the pack. They don't want to suddenly find in 7 years' time that half of the cars out there, because they've been DC fast charged a lot, are all dying. And they have to pony up the replacement pack, which is going to cost them a fortune. So I think they're being super cautious. So whether or not that is a learned experience from the previous models or not, I don't think so, because the Ioniq hasn't been out long enough for, I think, there to be any issues with the packs. So it isn't like the Leaf, which has been around for 9 years now, right? And a lot of those old Leaf packs are dead. Right, they've lost, they've lost a crap ton of capacity, and they've had to change a lot of those under warranty. So they
started at low capacity too. So then they're like basically, you can use this to drive around the block and come home, and that's about it.
And come home, and that's it. Yeah, it's basically a novelty. If you buy an old, 2012, 2014 Leaf, it's like a novelty car. Clown car, and. Anyway, it's interesting. So I was puzzling. I knew the car was doing this, but I didn't. Yeah, somebody's published a graph, and I think I might go out and get my own graph. I might discharge it to like 5%, go to one of these things, put a camera on it for an hour while it's charging from 0 to 100%, and we can possibly see this step.
That's it.
Step response. So
yeah, this is interesting. I mean, it is interesting following your stuff here. It's for you. It's actually like how you get around. So like I get it's actually much more visceral for you. But like I am digging the other stuff that you're doing with like the bus thing. If people haven't watched those bus videos that Dave did, I thought that was really cool. Like that, and just like that is, I don't know, the fact that it's like it's just a bus, right? I mean, it's just like, it's just
it's just
like
a regular bus,
that
but
is
they put
like,
batteries
that is
in
the
it.
greatest hope for me. Like when solar panels got cheap, and it's just like,
Right.
oh yeah, it's just like a good economic decision. When buses are just, like they're,
Yeah.
the maintenance costs are better, and it's less diesel and it's cheaper, and it's like when it becomes like an economic decision, it's like, man, it's just like it makes me feel like warm and fuzzy, because I'm like, there's no way that that's not going to be the answer now. You know what I mean? Like it's not like,
Yeah,
oh
exactly.
well,
Right. It all comes
Yeah.
down to economics. Nobody really, when the rubber hits the road, nobody really cares about the environment. When rubber hits the road, nobody really cares about 3,000 people in Australia dying from air pollution
Sure.
due to vehicles
Right.
every year, right? You think
Right.
COVID's a problem.
Well.
Keyword. I don't think this will get indexed anyway. More people die from.
Well, in Australia, let's just make that clear. Yeah, the U.S. is a hot mess,
in Australia. Anyway, air pollution,
sure.
big problem, right? Which nobody gives a shit about. But when it comes, if it saves the money, you're damn right they're going to do it.
It becomes a like a non-political, like lifestyle issue. It's
totally.
Just literally just money, and like, oh man,
I
love that, because
the market will solve
because
the
for
problem.
me it is like a
solve the problem
visceral
if there's
thing. Like
money
I
in it.
want it to be like this, and like when the money lines up with it, it's like, oh hell yes.
Yeah.
Beautiful. And like the other stuff you said too, it's cleaner, it smells less, it like it's quieter, like all these other things are great too. But once the money lines up, boom, yes, that's the answer.
That's it. It's done it. Yeah, it's done. So anyway, I think this is a very interesting example. I'm going to have to dig up more data on this, and if I can, then I might do a video on it. This is preventative cost engineering. This is preventative. What would be the correct term?
Designed for longevity.
Preventative because they're designed for longevity. Designed for product longevity. Yes. Because in this market, they've been forced, when, 20 years ago, if you bought a car, you were lucky to get like a 1 year warranty on it, right? Like, you get 3 years on it. It was a big step when they went from 1 to 3 year warranty. And then some manufacturers came out and went, well, for a 4 year warranty, then 5, and then it was 7, right? And now it's like you buy a new car and
new powertrain warranties come for 10 years or 10,000 miles, 100,000 miles.
And 10 years. I know. Exactly. An 8-year battery pack warranty. And that's gutsy, right? That's ballsy when you don't have 8 years worth of data on those.
Actuarial nightmare. Some actuarial is like sitting somewhere just like biting his nails, just like peeing his pants.
I know, it's just like having convulsive fits because, it's caught up in the fetal position. Yep. And so I reckon they've deliberately implemented this really to be on the safe side. So I'd love to talk to the engineers responsible for coming up with this step-based algorithm and what their rationale behind that was. And I'm sure it is 100% preventative pack longevity, because the biggest risk to an electric car battery pack or an electric bus or whatever it is, electric truck, is fast charging. That really damages it. Like if you fast charge every day, your pack's not going to last very long at all. And they actually warn you in the manual, look, you can fast charge this, but don't do it all the time, because you'll just, shorten your battery life. Guaranteed. So interesting. So
cool.
There you go. Sorry, we're way over our amp hour capacity. We were designing for longevity this episode. Hey, that could be the name of this episode, Designing for Longevity. Nice. Ah, yes, it always comes out, doesn't it? Name just presents itself.
All right, so Luigi on Twitter, he gave me a potential sign-off, so I'm going to try it here today. You know how like I always say what you say, and then I'm like, that's not what I'm supposed to say. Here we go, though.
Wow.
Like when we sign off, like you always say, like, catch you next time, right?
Catch you next time.
Here we go.
Yeah.
Ready?
Yeah.
Thank you for listening.
Okay.
May all your blinkies shine brightly.
Okay. Catch you next time.
This episode was produced by Analog Life LLC and brought to you today by our patrons. Join at patreon.com/theamphour to get access to our private Discord and discounts on Amp Hour swag. A special thanks today to our corporate sponsor, Bino, makers of the Bino Nova.